Welcome to the Energy InSites podcast, your source for the latest insights in deep retrofits, renewable energy, and energy conservation. Now, let's get to today's insights. My guest today is Aura Lee MacPherson. She is a nurse who ended up rethinking how we heat homes. Her Blanket of Warmth project has won an APEG's Exceptional Engineering Award and a Canadian Green Building Award. And she was also honored with the CTV News Regina Citizen of the Year Award in 2022. And her work now warms more than a dozen First Nations homes in Saskatchewan. Aura Lee, welcome to Energy InSites.
Oh, thank you so much for having me. But what I always say us because it's always a team behind you. So we always say yes. So thank you so much. I'm really looking forward to chatting with you today.
Yeah, you know what? I was really surprised and excited to get to know you and to get to know your project. Obviously, we were connected through Robert Bean a little while back, one of our early guests on the podcast, and he highly recommended you and your work. And as our team has gotten to know the Blanket of Warmth project, we just think it's amazing. And we really want to share that with the rest of Canada and the rest of the world and whoever's out there watching this. If you're a homeowner, a building owner, asset manager, housing department operator, this podcast is for you. You know, we deal a lot in deep retrofits through the Energy InSites program. And one of the challenges that we face is what to do, when to do it, how to do it, what technologies to use and why to use them. And of course, these days, how much they cost. And so one of the things that we got real excited about your solution is that it comes from a slightly different motivation and inspiration and is a very pragmatic, practical, affordable, realistic, attainable, like doable, minimally invasive, just a smart solution. So why don't you tell us a little bit about yourself and how you got to be in this space and the solutions that you've come up with?
Oh, thank you so much, Kevin. First of all, I just have to thank the team. I want to show gratitude, and I would not be sitting here if it wasn't for my husband, Murdoch MacPherson, who is a mechanical engineer. I am not a mechanical engineer technologist, so I can't speak, that language. And just like you mentioned, I have a nursing degree, which is a degree, and I got it just after the dinosaurs died in 1983. But it was a degree of empathy. It was a degree about listening and about compassion. And that served me well. Anyways, when we started the Blanket of Warmth project, we knew, because when Wendell and Sonia came to us and asked for help to look at their home, because it had mold, and Wendell was very concerned that it was making his wife sick. So the house was making her sick. That was a really good question to ask, and it took a lot of bravery. So I want to thank Wendell and Sonia for asking that good question, but also to Nicole Miller, because when we went into this, Wendell said, "This is a wicked problem." And Murdo and I are like, who do we think we are that we could deal with a wicked problem? And Nicole Miller, we said, "Nicole, would you help us on this project?" And within a millisecond, she said yes. And so really, Kevin, all you need in this world is a friend, one friend who says, we'll try, we'll jump in on that and see if we can help. So Nicole Miller gets a great deal of credit, but also then we reached out to Dr. Hanny and the U of R, and we used the capstone students. And maybe we can talk a little bit later about how the capstone students just bring a real sparkle to any project. But then it was like our local lumberyard store, Fry's Tallman, they leaped in and helped us. Every time we said we needed help, people helped us. And so that's what inspired the Blanket of Warmth, is that other people jumped in. So you asked, what is my background? So Murdo and I started MacPherson Engineering 30 years ago. And we're now a company of 18. We never believed we would have the success that we've had. But mostly it's because meeting people like Robert Bean and Ashray, we really believed in connecting and educating, but also sharing knowledge. So I was really impressed. I listened to a podcast. You had Mark Bernhardt
Yep.
on, and he talks about how it's really important to share knowledge. And I think that's the big shift that we're seeing, that all these climate event changes are happening. It's like, hey, we can no longer be in our little gopher holes. We have to work together and work as a team, and we have to share knowledge. And so that knowledge sharing is real big, real big.
Absolutely.
So, yeah, so that's
It's
sort of
one
how
of
I
our
got.
main motivations for having this podcast, actually. You know,
Mhm.
the Energy InSites program is largely an Indigenous centric program. And so this content is largely for that audience, but we wanted to make it available to everybody on the planet, and to share in that. Podcasts are interesting because it's kind of a modern incarnation of that oral tradition, right? Of talking,
Yes.
of sharing
Yeah.
information, and doing it in a way that everybody can benefit from. And it's just been super, super fun and interesting and educational for me. I mean, I know a fair bit, but I'm learning something every time I talk to somebody new. And so grateful for all the guests that we've had on, for Mark, for Robert, for everybody else. And they've made more connections like yourself. And so, this is just I think it's a wonderful forum to share that information with people, and hopefully they get value out of it. And some of them will take this inspiration to their own communities and their own homes and businesses.
I think that is so important for humanity. If we're going to face what we have to face, it's having these conversations in spaces where we respect each other's knowledge. Because we came from a colonial, like, we know what's right, we're doing this. It's like, do we? Do we?
Right.
So,
And that's a good segue. I remember one of my mentors, eco builder named Paul Belanger. I hope to have him on one of these days, and I would like to connect you with him. He would tell the story of the wall tents, the canvas wall tents that the settlers brought in, and how the indigenous folks would kind of laugh at it, because they were all in teepees,
yes.
and we thought, oh well, our shape is kind of better or whatever,
Yeah.
the British
Yeah.
way.
Yeah.
And yet when the first storm hit,
Yeah.
there goes the four wall canvas tent, because it's just a big sail waiting
Yeah.
to be picked up and thrown away. And in fact, if you fast forward to today, even in our modern cities where we build everything in a box shape,
Yeah.
um, when a hurricane or a tornado comes along, those are the
Yeah.
houses that get ripped apart. Whereas when you build in the round, when you build in the cone shape of a teepee, yes, there's some, people might say it's inefficient because the walls aren't, where you can stand at the perimeter, but it sheds the wind.
Yes.
It's less heat loss. It's actually less material for a given surface area of square footage. And so when you go to Florida, I'm a big fan of geodesic domes. Oftentimes it's the monolithic domes and the dome shaped homes that are the one that's still standing in the community
Yeah.
that got leveled.
Yeah.
And so, building in the round TP shapes, octagons, these tend to be more resilient structures.
Yeah. And for like we just a segue there. That's what when we went into this when we went in when Wendell said, "Hey, can you look at our home? The house is making us sick. It's got mold." Um and he called it a wicked problem, and it's like, whoa, 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 whoa. And so that's when we were humbled, and we said, we can't do this alone. And so Wendell was very generous with sharing knowledge about how the teepee worked. And so we started to learn. And it was like when you're in the engineering business, like you're productive, you're putting one foot in front of the other. And Wendell shared, no, no, you need to stop and pray. And we're like, that was so foreign to design for us. But we did it. We And in that process, we learned so much about indigenous ecological knowledge, which I didn't even know existed. And so we started our journey of learning and respecting First Nation knowledge. And then we just said, okay, let's weave the two together with the knowledge of ASHRAE, but also with the knowledge of the United Nations, because we were stumbling. And when you meet someone who has tears in his eyes asking for help, it's like, okay, all hands on deck. Who do we know? Let's get every single person in here and try to make this better. So that when we look at the blanket of warmth, we say that the big innovation wasn't a technical innovation. It was the three knowledge bases coming together, just like Robert Bean says, I can't remember the word that he used. It was like integral design, that we're bringing everybody together, respecting the knowledge, and just trying to do better for humanity is what we
Yeah.
did. So,
Yeah. I find your story really unique in that you came at, like, most of what we do is coming at things from a technical energy conservation. We want to save money, is kind of
mhm,
one of the big motivations. The other is GHG reductions, which has been kind of a federal mandate for a while now. Um, but you came at it from a public health standpoint and still ended up in the same place. You
I
still ended
know.
up in energy conservation. You still ended up in sustainability. You still ended up, in GHG reductions. And so, but that's so foreign.
Yes.
Tell us a little bit more about that.
So how I got to know about the United Nations 17 goals is I was doing some volunteer work trying to save the water in the Qu'Appelle River system. And we held just a little community meeting, and the university came out. A community meeting is powerful. And the university said, what do you know about the United Nations and the 17 goals? And I said, nothing. And they said, okay, we're going to mentor you. And so I would go to these classes for a couple hours for 6 weeks. And I learned everything about the United Nations and about the 17 goals. And I was really, really impressed with the 17 goals because, first of all, it gave me and our company a definition of what sustainability is. Like it's a term that's thrown around a lot, but it
Right.
often has that bottom line part to it. Whereas, so the definition we took was enough for all forever. So it
Mm,
means you can't be gluttonous. You have to think about, which aligns with First Nations because when they make a decision, they're thinking 7 generations out.
right.
And I'm like, whoa, that's pretty cool. So then when and we're stumbling, we're just stumbling. When Wendell asked us for help, I went to Murdo and I said, Murdo, I would like to manage this project, but I want to explore the 17 goals and use that as our bouncing off for decision making. So we learned that. So goal number 17 is partnership. So we
Mm.
saw that and it's like, okay, let's phone the university, let's phone Cole, let's phone Bryce Tallman. And that was the first thing we did. And what Dr. Roger Petrie taught me in those mentoring classes was that the 17 goals give you the opportunity to ask the good question. So we always kept, equity in our back pocket, sustainable cities in our back pocket. So when we made a decision to go and buy drywall, we didn't look for where can we find the cheapest drywall. We looked to our community. And it's because we know that those businesses are providing decent jobs. So we paid a little bit more, but we didn't because they always gave us stuff. And we
Right.
so community minded. And so that I think was what really helped the blanket of warmth is that we were up against a wicked problem, but we had this tool to ask the good questions. We always had to say, did we address equity? Did we do this? Did we do that? But when we partnered with Dr. Henny at the U of R, and we had a capstone student project, and they were just three of the most amazing students ever. But what happens when you work with the university and these engineering students is they come into a problem with fresh eyes. And so they see, like, we're just like, oh, we're seeing the engineering part of it. But they were the ones who said, did you see all the space heaters in the basement? And I'm like, no, what are you talking about? And then I said, could you do a dive into that for us and see what you can find about space heaters? So then we learned that space heaters are from November to March, or 79%. If you're going to die in a fire, that's the reason.
Mm.
So those are
Oh,
big.
wow.
Yeah. So it's like, oh my gosh, the mechanical system is setting this family up for failure. So we're in the mechanical business. Let's do better. How can we do better?
Yeah, so they had a gas furnace in the
Mm-hmm.
basement pushing air into the main part of the house,
Right.
but the basement itself remained cold and damp.
Yeah.
And then they were throwing space heaters into the basement. Was it lived in, or was it an unfinished basement in those
It's a,
cases?
it was unfinished, but it had been drywalled on and insulated on the inside. They wanted the space to live in, but it was cold, damp, and you could see the mold.
Mm, creeping
And
up the wall, kind
yeah, it
of
was on the
coming in
floor,
from
it
the
was going up the
bottom.
wall.
Yeah.
Yeah. Um,
And so they were doing that, like they still weren't living in the space, but just to make it more tolerable, or was that
yeah.
their own solution to the mold, like, or were they not connecting the dots at that point?
I think it goes back to what Robert Bean says, is that we often design beautiful buildings, but we never take into account of it's human centered.
Mm-hmm.
It's so the bungalow that they were living in was very much a colonial design. It doesn't take into the cultural and social aspects of how people move through that building. And going back to the United Nations, we landed on our definition, which is enough for all forever. But there's four pillars to sustainable development, and that's economy, environment, social, and culture. So when we design at MacPherson Engineering, we always talk about how much something costs. Maybe a dribble on the economy. We never have conversations about social and culture. And that's what Robert Bean is all about, is that feedback loop to the people in the space.
Mm.
So the basement was cold, damp, and musty. That's where they did their laundry, was down in the basement. And they used it as storage for ceremonial items. So these are precious, precious
Mm.
items that are
Right.
in a mouldy basement. Um, so that that's humans, like Robert says, we will go and try and find comfort wherever we can. And often it's at a big box store on the end shelf, and it's like 1,500 watts. That's got to be good.
Right.
Plug that in. But then that affects their energy security, because or creates energy poverty, because
Yeah, bills are going up.
so the HVAC system didn't do the HVAC system was, the way we look at it now, was a colonial design. So, anyways, how about, Kevin, if we show the video?
Great. Yeah. Yeah. I think people are really keen to see kind of what this manifested as, what
Yeah.
solution, and who would you. I mean, obviously it's a team approach, but in terms of the genesis of and we'll see it in a second, the wall board hydronic system. Was that the students? Was that their lead? Was that the Uponor rep? Or
No, that was Murdoch. We in 2012 we did the Regina jail,
oh wow,
and we knew when he was designing that, and he won an ASHRAE award for it. He knew that if you put the hydronic in the ceiling, the top bunk is not comfortable, and if you put it on the floor, they can be too hot. And when you're dealing with a fragile community, like in a prison system, you don't want somebody too hot or too cold. Like it can
Right.
trigger unhappiness very quickly. So the idea came to put it in the wall. So we had been exploring this for quite a while. And we had another project, AODBT, which is a architectural firm in Saskatoon. They bought an old warehouse and they didn't want to disturb the floor. So we put the PEX piping on the wall. So we had been,
Hmm.
but we had never, we knew that we were confident it would work, but industry wasn't ready for that. And it really hadn't been used much. But
Yeah, and so while you're queuing that up, I'll just say a brief story. So even in my own home, we ended up doing a basement underpin, and we took the extra time and money to do an in slab hydronic system, and it is amazing. I love it. I'm so glad we did it. It's warm underfoot. It's very efficient. It's a really comfortable basement compared to so many that are cold and damp. And then when I was researching that, I saw they also had a system for doing it in the ceiling of a space. But I had never heard and seen anybody do it in a wall. And so I'm really excited for you to share this. We've queued up the video and we are going to let everybody see the Blanket of Warmth project.
Blanket of warmth. That's where we get our you know our good feeling, you know, when we're cold, and good feelings when we have negative energy sometimes, and it lifts us and it brings us warmth and it brings us energy to do more things in life.
It actually started here on Treaty 4 ground, and I had the pleasure of working with Wendell Star Blanket on some volunteer work I was doing.
I told her about a dream and a vision I had for First Nations people, and that's to help them address the water issue, water treatment plants, mold, those types of things. And she says, well, we have, interesting that you should talk about that, because we've developed this system.
We figured out an easy way to use your house furnace and distribute the heat better. So rather than blowing the heat out with warm air, which results in rising heat in cold basements, we basically take a certain amount of that heat, turn it into hot water, and circulate it through radiant piping applied to the basement walls.
So we thought, well, we can't do this by ourselves. Let's bring in the best and the brightest that we know.
One of Uponor's main core values is to create better human environments. Uponor is a pipe manufacturer, so we manufacture PEX tubing for radiant heating, plumbing, and residential fire sprinkler systems. And so we first got involved in this when Aura Lee had contacted me with Wendell and Sonia's situation with the mold in their home. So both of our joint products come together to create the solution and solve the problem. Essentially, we take the existing furnace, and MacPherson Engineering has come up with a product called RadiantLink, which essentially is a coil that heats up the water going through the pipes as the furnace is running. So once the water is running through the pipes over to the pump keeps the water circulating and reheating through the coil. It only has just a very thin insulation, and so that allows the conduction of the heat from the pipe to go to the cement and create a thermal mass. So basically what that means is you're using the whole cement wall behind the heat to create the heat. The data shows that this home was very, very sick.
As you can see behind me, this board I built myself along with my Aboriginal employees. This offers us an opportunity to provide employment to First Nations people in the sector and also bring wealth to the community. We've taken this project on because it gives us an opportunity to bring First Nations housing up to a healthy medium for our people.
I teach a course called Capstone Project. So this is the final year project for all engineering students. There are two parts in the project. One is to compare the house where the system was already installed to a new house that didn't have the system, and compare, the temperature variation, humidity levels, and so on, energy consumption and electricity consumption, and so on. Second part was to help, design and install the new system in the new house. And they were very proud. I think they were very emotional even to talk about it when they started presenting their results.
The 17 goals of sustainable development, number 12 is my favorite, and that's about responsible consumption and production. And that's what this project was all about. It's like, we are not going to throw all these houses in the garbage. We are going to look for the assets and make them better, and that's what we did.
It's improved our living conditions, our breathing conditions, our allergies, our asthma, they've all disappeared. So it's been a complete turnaround in our health.
It starts at home, self-worth, self-value, Lots of our structures for our families, they're subpar in that, and that has a lingering effect on our attitudes in that, because we come from a place where things aren't even up to date as they are off reserve. And this gives us an opportunity to bring not only our home fires up to a healthy standard, and that, and then we know we deserve better, not only ourselves, but as a people.
The more homes we get it in, the more homes we're going to save, the more lives that we're going to improve.
It's all about healing our people and making sure that they have a good life, that they live a good life. And I believe this project is so important that this project will do that.
Wow. That's amazing. Thank you so much for that. What a inspiring story, so many people coming together, starting from a public health problem, turning it into an engineering solution with, it's complex, but it's simple. Right?
Yeah.
It's like there's a lot of research that goes in behind it to figure it all out. But then once you actually spit it out the other end, it's a very straightforward system. We tend to overcomplicate things a lot. And then we end up with, especially in the rural and remote communities context, where they'll have some kind of fancy solution and nobody in the community that can service it. Or maintain it, right? And then that eventually breaks down, and now you got to fly somebody in. We've heard that story so many times that it shies people away from doing some of these most innovative things that we have available to us today. This is an existing furnace, and now you ended up with massive energy savings. So, correct me if I'm wrong, it's a combination of eliminating the electric space heaters, which I know we're trying to electrify things,
right?
But in this context, was maybe not the most cost-effective or efficient way of doing it. And then I'm assuming also it actually helps like the forced air system perform better.
Yeah, that's a really good question for Murdo. Because I'm not an engineer, it's hard for me to answer that. But when we went into this project, we weren't looking for energy efficiencies, Kevin. We were looking for, let's make this house healthy, because if the occupants aren't healthy and it's a fragile community, you are not setting them up for success. If you're too hot or too
Right.
cold, you will make the wrong decisions. So we knew that not only if you can make the house healthy, you make the people healthy, you make the community healthy. And
Right.
humanity is better for that. It was just a sidebar that we saw the space heaters, but I didn't see them. It was the students who saw them. And so they were the ones that did the data dive and said, you need to look at this. And so it was, we were just stumbling, Kevin. We were just stumbling. But because we had met Sonia and the community, it's like they are way too good to have to live with mold. So let's try our best. And that's what we did. And we just connected with incredible people like Robert Bean. Like every time I'm around Robert Bean, he's like, what did you say? What are you talking about? Exterior shading on the outside? Let's talk about that.
Right.
It was just all about connecting and doing better.
You know, you mentioned a story about taking inspiration from the teepee. And I find this very timely, because we do talk a lot, and I personally have talked a lot about adding insulation. And the analogy I've used in the past is, buildings in North America are basically on life support. If you pull the plug from, your furnace or your boiler or whatever, like wait a couple hours in the winter and, you're in trouble and your pipes are freezing and whatever. And whereas when you have a thick wall, I'm a big fan of straw bale. I'm a big fan of some of these kinds of centuries old ideas, really, that we've sort of forgotten about as we went to cheaper construction methods in the early 1900s. And we're sort of slowly getting better and back to that. But when you have a very thick wall, you can really store a lot of that heat. Your furnaces don't have to work as hard, and so on. And it's a passive system. You pay a little bit more upfront to put it in, and then you're largely, having lower op costs. But your concept kind of flips that on its head when you describe how a teepee stored the energy in the rocks around the fire. And when you think about a teepee's shell being actually very thin, maybe it was a fur based or sort of canvas based. And that runs totally the opposite of what we think about when, I need a thick wall, I need lots of insulation, R values, and so on.
Yeah. So when we got the students to do a dive into the teepee, and Wendell helped us with that knowledge, is we learned that the rocks are not in the fire, they're around the fire. So that they knew that the rocks could absorb the heat and store it for them. So when the fire went out, they still had warmth, but they didn't have to exhaust the natural resources to make sure that fire is going. And so that was a real big thing. But straight up, Ken, we had no money. When Wendell did this, the smartest thing, he didn't ask us if we could solve the wicked problem. He said, could you come out and have a look at it? Which is a really interesting way. So we went out and looked at it, and Murdo said, yeah, we can fix this. We can change the dew point by changing how we distribute energy in the house. And I said to my husband, Murdo, we don't have $8,000 to fix Wendell's house. Where are we going to come up with this money? And he was the one who said, phone Nicole, she'll help us. And I often tell this story. I can't tell you, Kevin, when I made that phone call to Nicole asking for help, I paced my office because if she said no, I had to say no to Wendell.
Mm.
And she said yes like that. And it's like, okay, here we go. Let's give it a go. So what we were just stumbling, and we're just trying to be neighborly, and we're just trying to be compassionate. And we knew that we didn't have $100,000 to fix Wendell's basement. So it's like, okay, what's plan B? How can we make sure that Sonia is safe in this house? And so we just stumbled on this. And PEX piping is pretty inexpensive. The fast track is pretty inexpensive. It's easy to go through a wall. You just use your X-Acto knife and blaze through and then putty it up. So we just looked, we just reached out to everybody and said, what do you think? How can we do this better? And when we designed the control panel, we designed it like it was going into a commercial space, because that's what MacPherson Engineering does, is commercial spaces. And Nicole said, yeah, you can use the $300 manifold with copper, or what do you think about this one for $50? This PEX pipe was like, let's try that one.
Yeah.
So we just respected everybody's knowledge and tried to do our best. And the teepee was really pivotal for us, because it's like, let's study this teepee. Let's learn all we can. And I really believe that we haven't really studied thermal mass enough to know what it. I think we have a very colonial view of what materials can do for us. Whereas the First Nations, not only did they use the rocks have a sacred meaning, and I'm still trying to figure that out, but I think they're called father rocks, and they represent the father and the wisdom a father brings to the family. So they're very, they knew what they were doing, but we're not respecting that knowledge. We're not incorporating that, so that, and I really believe if humanity wants to move forward, we all go forward. We're not leaving anybody behind, but we have to respect knowledge.
It really is interesting when you think about all the hundreds and hundreds of homes we've all visited in the cities. And they all have a similar thing where they've got a, usually it's a natural gas furnace, forced air furnace in the basement, kind of maybe in the middle or tucked away. And it's just pumping the hot air to rooms. And it's kind of ignoring the, tens of thousands of pounds of essentially rock, i.e. concrete or, brick or whatever that's underneath it, around it, on the walls, all the way up to the roof, maybe in some cases, maybe not, but just like all the way around the basement for sure. And we don't dump the heat into that and let it radiate out through the house. Number one. Number two, when I shared this concept with one of our team members, Sean, she immediately, I initially thought of it as like, oh, you're losing a little bit of wall space because now you've got this little jut out, 3-6 inches, whatever, and then you got to drywall it in. Like, and my comment to you was, hey, don't hang any pictures, haha, because you're gonna pierce the hydronic, and that's what my mind always goes to, is like people piercing it and then causing a problem. But two things came out of that. One was, you had mentioned it's a closed loop system, so it actually it's not tied to the municipal water line. No. So if you happen to accidentally pierce it, you're not flooding out your entire house for hours and hours while you're away at the grocery store or wherever. It's like 5 gallons, like and then it's done, right? So that was an interesting thing, number one. And number two, what she said is she would actually pay a premium for this because it gives a shelf. And she loves the idea of, like, little trinkets and knicknacks and pictures right at that 3-4 foot level. That is actually really cool. And so I hadn't thought of it that way, but I just I love that it does have some other aesthetic value if you shift your perspective a little bit.
Yeah, yeah, it does. When you showed the video, I can't tell you how proud I am. Like, I think we're creating HVAC art is what we're doing. Is we're and it's only when you're in the HVAC industry do you ever say, "Oh my gosh, I think that's HVAC art." Because most
Oh yeah.
people don't, in their furnace room, they don't look at the furnace like we look at the furnace.
Yeah.
And so we totally understand we need to electrify, we need to move, but there's a few things we have to clean up, especially in Saskatchewan, using coal before, that's, the light, that's, we've got some work to do.
Yeah, the grid emissions intensity.
But
And of course, this doesn't preclude you from upgrading your furnace. You could still go to a higher efficiency furnace and do this. One could go to, solar panels and an electric forced air furnace. And so you could still decarbonize, you could still electrify, you could even go to solar hot water on the roof, a solar thermal system, and still heat exchange that into the walls in the basement. So there's like some super renewable versions of this.
So we, like I said in the video, goal number 12 is one of my favorite. Goal 17 is partnership. I like that one. But goal number 12 is really about waste. It's like we need to rethink how we look at waste. And so that furnace, if we take it out and put a heat pump in, it still has embodied carbon. It hasn't aged out. So how can we take that equipment that hasn't aged out and make it better? Now, when it ages out, let's have the conversation. What should it be a heat pump? And that's the next thing Murdo and I are really curious about is, can we put RadiantLink on a heat pump? Because we think it's very, like a heat pump. Heat pumps are expensive, but a water to air heat pump is really expensive. And so can we make that heat pump that is somewhat affordable, can we make it a little bit better with?
Yeah, well, that's a really great topic. I think we need to have Murdo on another episode with him just to get into some of the other mathy bits of some of this and some of these more novel on the horizon approaches. So we've talked about the past, we've talked about the present. Maybe we'll save that for the next chat on kind of where this is all going. But Aura Lee, I just want to thank you again for the work you're doing. It's so inspiring. It's truly helped this community. I know for a fact that a lot of our communities have the same challenges and that they don't know about this solution yet. So I really hope that this podcast finds them. I really hope that they reach out to you. And so for folks that are interested in working with MacPherson Engineering or getting a RadiantLink set up on their furnace, how can they get in touch with you?
Probably the easiest way is a phone call. They could just phone me at 306-539-6903, or they can email me at a.mcpherson@mac-eng.ca. Love to have a conversation. Love to come out and visit them. Love to see what's going on. I'm really, you sparked my curiosity about northern Canada. We need to have a conversation about. Kevin, one other person I'd really like to connect you with is my sister, who's an architect in Edmonton, and with the housing accelerator funds, the challenges we're having to do this challenge that we have about creating more houses. Innovation is kind of locked out. Like we're not having the holistic conversation where it's still kind of like when you mention in-wall to some mechanical designers, they're like, whoa, what do you do?
Yeah, well, you know what? This is a great topic for us to maybe take offline. The LEAP group is doing a ton of work in this area. We've got some great connections with some folks that are in the modular housing and prefab world. We know that a lot of our community partners are super keen to bring jobs and skills back to their communities. They want to be building the houses that their community needs in the community. And interestingly enough, some of them used to do that. and they've
Yeah.
slowly lost those people or those skills over the decades for various reasons. And some of the younger leadership is super keen to bring it back. So we'll park that for another chat, and I look forward to meeting your sister. So if you want to set that up offline, I'd be happy to.
Okay.
And we'll get Murdo on here, and I'd love to have you back in a couple months, and we can sort of see how things are evolving.
Thank you so much, Kevin. It's just, I can't tell you how nice it is to have chats like this. Yeah, I really, really appreciate it. Your podcast is moving the dial.
Thank you so much. And thank you, everybody. I hope you got some good value out of today, and look forward to the next one. Take care.